Welcome back, everyone, to the deep dive. Yeah, I got to say, I've been spending a lot of time recently thinking about terraforming Mars.
Terraforming Mars.
This whole idea of turning the red planet, into a place where humans could actually live, like a second Earth. That has just been kind of blowing my mind.
Yeah, I get that. It's one of those things, right? It feels like science fiction, but then when you really dig into it,
It's not that crazy.
well, it is crazy, huh? But like, in a way that makes you think, hey, maybe we actually could pull this off someday. And the side-by-side episode we looked at really gets into all of that. So what we want to do here is kind of go through all that, pull out the coolest stuff, the things that really made us go, whoa.
Exactly. And, when you look at all the planets out there, Mars is kind of special, right? I mean, it's got a day and night cycle that's pretty close to ours here on Earth. It's got those polar ice caps, which means there's water ice there. And there's a ton of evidence that way back in the day, Mars actually had rivers and oceans. Liquid water.
Right. And that's what makes Mars so fascinating. It's like this almost Earth that went wrong. But then, of course, there's the reality of Mars as it is now, bone dry, frozen, with this super thin atmosphere that you definitely can't breathe.
Right. So the big question we've been asking ourselves going through all this material is, can we actually do it? Could we really terraform Mars and make it a place where humans could actually, I don't know, walk around without a spacesuit? Like, what are the biggest things standing in the way? And what are some of the ideas people have for getting around those problems?
Yeah. So I think a good place to start is with the atmosphere, or should I say the lack of atmosphere. I mean, one of the things that really jumped out from the side-by-side episode is how incredibly thin the Martian atmosphere is. Like, it's only about 1% as dense as Earth's atmosphere.
Oh, okay. So what does that mean, practically speaking?
Well, it means liquid water just can't exist on the surface. It would basically, boil away instantly. And of course, there's the whole problem of radiation. Without a thick atmosphere to protect you, the surface of Mars is getting blasted by all sorts of harmful radiation from space.
Right. Okay. So back to that atmosphere, or the lack of it. The side-by-side folks talked about a few ways we might actually thicken it up, right?
Yeah, they did. And one of the most interesting ideas is to try and use what Mars already has. You see, it turns out there's actually a lot of carbon dioxide, that's CO2, locked away in the Martian ice caps and in the soil. And CO2, as you know, is a greenhouse gas.
A greenhouse gas, meaning it traps heat.
Exactly. So the idea is if we could figure out how to release all that CO2, it would cause a greenhouse effect, warming up the planet and thickening up the atmosphere.
Okay, so how do we release all that CO2? Like giant Martian hair dryers?
No, not quite. There are actually a few ideas floating around. One is to use orbital mirrors to focus sunlight on the polar ice caps, basically melting them and releasing that CO2.
Orbital mirrors? Like massive mirrors in space.
Yeah, exactly. Huge reflective surfaces that could redirect sunlight onto specific areas of Mars.
Whoa. That's pretty wild.
It is. And of course, there's the more controversial idea that Elon Musk has talked about, nuking the poles.
Nuking the poles? Seriously?
Well, the idea is that the explosions would release a ton of heat and vaporize the ice, which would then release all that CO2 into the atmosphere. It's a pretty extreme solution, to say the least.
I can imagine. Okay, so let's say, for the sake of argument, we managed to thicken up the atmosphere. Problem solved, right?
Not quite. You see, even if we had a nice thick atmosphere on Mars, it would still be mostly CO2. And we can't breathe CO2.
Ah, right. So next problem.
Yeah.
We need oxygen.
Precisely. And luckily, there's already been some pretty cool progress on that front. I'm talking about the Oxy experiment that NASA sent to Mars.
Oxy? What's that?
It's basically a little device that can suck in Martian air and produce oxygen from it. And get this, in 2021, it actually worked. They produced oxygen on Mars.
That's incredible. So we know it's possible, but obviously a little device like that isn't going to create enough oxygen for the entire planet, right?
Definitely not. We'd need something way, way bigger. And there are a couple of main ideas for how to do that. One is to use genetically engineered organisms, basically algae or bacteria that could survive on Mars and produce oxygen as a byproduct of their, normal biological processes.
So like microscopic oxygen factories.
Exactly. The other idea is to build massive industrial plants that could extract oxygen from the Martian atmosphere and release it into the air.
Like giant air filters, but in reverse.
Yeah, kind of like that. But of course, building and operating something like that on Mars would be a huge engineering challenge.
Okay, so we've thickened the atmosphere, we're making oxygen. What's next on our terraforming to-do list?
Well, we can't forget about water. I mean, sure, Mars has polar ice caps, but remember what we said earlier, liquid water just can't exist on the surface with the current atmospheric pressure.
Right, it would just evaporate away. So how do we get liquid water on Mars?
Well, some of the ideas we talked about for thickening the atmosphere could help with that too. Like the orbital mirrors. If we could warm up the planet enough, we could potentially melt some of that ice and get some lakes and rivers going.
And what about that comet idea? Crashing comets into Mars.
Yeah, that's another possibility. It sounds crazy, but if we could redirect an icy comet and slam it into Mars, it would deliver a whole bunch of water. Plus, the impact itself could potentially help to kickstart a water cycle.
A water cycle, like rain and clouds and stuff.
Exactly. Though, of course, getting that whole process going would be incredibly complex. We'd need to figure out how to create the right atmospheric conditions for rain to form and for water to cycle through the environment.
Sounds complicated.
It is.
Yeah.
And then there's the whole question of radiation. Earth has this magnetic field that protects us from harmful radiation from space, but Mars doesn't have that.
So what do we do about that? Lead umbrellas for everyone.
Haha, not quite. There are a few ideas, but none of them are easy. One is to just build everything underground, have people live in shielded habitats below the surface.
Okay, so kind of like living in a Martian basement.
Basically. The other idea, which is much more ambitious, is to try and create an artificial magnetic field around Mars.
An artificial magnetic field? How would we even do that?
It would involve putting giant magnets in space, maybe in orbit around Mars, to create a kind of protective bubble.
Wow, that sounds like some serious future tech.
It is, and it would be a huge engineering challenge. But hey, if we're talking about terraforming an entire planet, we got to think big, right?
Absolutely. Okay, so we've talked about all these different pieces of the terraforming puzzle. But let's be realistic. How long would all of this actually take?
Well, that's the million-dollar question, or maybe the trillion-dollar question. Haha. I mean, the estimates vary wildly, depending on who you ask. Some people say it could take centuries. Others say it could take thousands of years. And then there's some folks who think it might be essentially impossible with our current technology.
Thousands of years. Wow, that's a really long time.
It is, and it brings up all sorts of questions, right? Like, how do you even plan for a project that's going to last longer than any civilization in human history? What kind of social and political structures would we need to make something like that work?
And what about the cost? I mean, terraforming a planet can't be cheap.
No, it definitely wouldn't be. We're talking about, trillions upon trillions of dollars, which, makes you think, is it even worth it? Are there better ways to spend those resources?
It's a lot to consider. So, after going through all this, what's your take? Do you think we'll ever actually terraform Mars?
Well, it's tough to say for sure. The Side-by-Side episode kind of left things open-ended, They said it's definitely possible in theory, but the practical challenges are enormous. And we might need some major technological breakthroughs before we could even think about starting.
So it's still kind of a long shot?
Yeah, I think that's fair to say. But even if we never fully terraform Mars, even if it stays this, red, dusty alien world, just thinking about the possibility, about what it would take to do something like that, it pushes us to think bigger, to push the boundaries of science and engineering. And who knows, maybe in the process of trying to terraform Mars, we'll discover new technologies or new ideas that could help us solve problems here on Earth.
That's a good point. Well, this has been a pretty amazing deep dive into terraforming Mars. We've covered a lot of ground, from thickening the atmosphere to creating oxygen, bringing back water, and even building giant magnets in space. It's pretty mind-blowing stuff.
It is, and it really shows you just how much we still don't know about everything. But it also shows you how much potential there is out there. I mean, if we can even conceive of doing something like terraforming Mars, who knows what else we might be capable of?
That's a great point to end on. So, to all of you listening out there, we want to leave you with this question. What do you think is the single biggest factor that will determine whether we ever actually terraform Mars? Is it technology? Is it money? Is it the will to do it? Let us know your thoughts, and thanks for joining us on The Deep Dive.